Okay, so just a reminder that I think the pre-lab 2 is still at the beginning of the class. Okay, hopefully you already submit it. Okay, let me share my screen and we can start talk about lab 2. All right, so today is lab 2. Okay, so lab 1 you did some DC measurement. DC means the constant like constant voltage, even the time change. Then today you're going to start to learn the AC signal, which is a time varying signal. When the time change, the voltage also change. I will show you later on the plot. There are a couple things you want to pay attention in the lab manual. Okay, the first one is the AC RMS calculation. Okay, so this table 2.1, is what you want to kind of know where you can find the equation to calculate the AC RMS value. Okay, so for example, if you have a sine wave, the AC RMS is just the absolute value of amplitude divided by square root of 2. Okay, and then it's the DC RMS. Okay, after you know the AC RMS, then you also should know the average value. Average value is always the offset of the signal. Then you can use this equation to calculate the DC RMS. Okay, right. So the calculation is not too hard, but sometimes you might get confused with DC and AC RMS. But just make sure you remember this equation. You should be fine. Okay, before I talk about the tasks, there is a big PPT I want to go through. The first one is function generator. Okay, function generator is what you're going to use to generate AC signal. This is a benchtop equipment in the lab. You're not going to use it for this semester, but it's good to know how this works, okay, and also how it looks like. So you see this little 2-pin here, or two pin out here. That's the channel 1 and channel 2. So this equipment can give you 2 signal output, right? And there are some little button here to help you to choose the channel, and you can like change the parameter of the signal. All right, so here is the equation of AC signal. Okay, so and then this is a plot of AC signal. Hopefully after this class, you should able to, like if I give you a plot like this, you should able to like write down this equation. Okay, or if I give you this equation, then you're able to draw this plot. Okay, so I can tell you right now, that's what you're going to see in the lab practical. So make sure you understand how this works. So for example, in this one, okay, in this equation, the A in here is the amplitude. Okay, the amplitude is where the middle point or offset of the signal go to the top point. Okay, so this is amplitude. And then the F here, that's a frequency. All right, so how to calculate the frequency is you know the period, okay, where the signal repeats itself every time. So that's a period. 1 over the period, that's equal to frequency. Yeah. So for example, if the period is 1 millisecond, then 1 over 1 millisecond, that's 100 hertz. I mean, 1 kilohertz. Okay. Then the B here, that's the offset, where is the average of the signal. Okay. So that's what's the meaning of each number here. Okay. So you should understand this. And also here, this is this as a sign means this is a sine wave. There are also different kind of signal, like you have sine wave, triangle wave, sawtooth, and also the square wave. All right, so that's the explanation of each number, each variable here. Okay. Any questions before I start to talk about this experiment?
I have a question.
Yeah.
So is this the DC offset, but it's also the average?
Yeah, the DC offset is the average.
Oh yeah, that makes sense. Thank you.
Yeah. Okay. One thing I probably want to mention again is that's a common mistake. You might like got the difference between peak to peak and amplitude. Okay, amplitude is from, as I mentioned, is from the middle to top point. The peak to peak is from the top to bottom. Okay, so most of the time amplitude is just half of the VPP. Okay, then let's talk about this task. Okay, task one is should be simple. You're going to use a function generator to generate a sine wave and also a triangle wave. Okay, I will show. Probably I can show you right now. So as we mentioned, you're going to use AD2 to generate the sine AC signal. So there is a wave chain here. So that's your wave generator. Okay, so if you open this, okay, basically there are two channels. You can use, right now I just show one of them. So that's channel one, which is W1. If you check the pin out, there's a W1. So that's where the signal comes from. So you can use those parameter, like change those parameter. You can have a sine wave, you can have a probably triangle wave, and you can change the frequency, period, amplitude, and also offset. So that's how you can generate a AC signal from AD2. Right, then you're going to compute the AC and DC RMS value, and then you measure the RMS voltage by DMM. Okay. Right, so that's task one. Should be pretty simple. Any question about task one?
So do we use the AD2 as well to complete task 4, which is the measuring of the RMS?
Yeah, you can use, if you have DMM, use DMM. If you don't have
Okay.
DMM, yeah, use AD2. So you need to answer, does DMM measure AC or DC RMS value? So if you are using AD2, you answer in the answer you mention you use the AD2. If you use DMM, you mention you use DMM to measure. Okay. Any other questions? Right, if not, let's talk about task two. Okay, so the task two, you're going to verify Ohm's law again with an AC voltage source. Okay, so in lab one, I think task two, you verify Ohm's law by using a DC voltage source in the LT space. In here, you're going to verify it in the real circuit. So you're going to build this circuit right here. Apply those parameter in your AC function generator, and then you're going to use DMM and AD2 to measure the voltage and the current. Okay, you're going to use DMM to measure the current because only DMM can measure current. Okay, one thing you need to pay attention here is remember in lab one, if you check the manual, it's already mentioned when you measure current, the ammeter need to be in series. And when you measure voltage, the voltmeter need to be in parallel. Okay, I can draw a second. Let me draw this circuit here. All right, so let me show you how you can do the measurement. So first of all, usually I start with the power source. Okay, here is the AC voltage source. So the AC voltage source in your AD2, probably you want to use channel 1. So that's come from W1 of your AD2. And then, okay, here go to the resistor. So you need a resistor from your lab kit. Okay, so that's connect to a resistor right here. Okay, then as we mentioned, you want to use DMM to measure the current. So current need to be measured in series. So you need an ammeter here. So something looks like this. And then the another side of the resistor go to the positive side of the ammeter. And I can show you where is the ammeter on DMM soon. And then to make a like current flow through the circuit, you want current go back to ground. Okay, so that will be the ground. Okay, don't draw like this. And then this back to the ground. So there are 4 ground pin on the AD2, so you can use one of them. And so that's how you measure the current. Then you need to measure the voltage. Okay, then you need a voltmeter here. So probably you can use AD2 as your voltmeter. So this is your voltmeter, and then 2 sides of the voltmeter connect to 2 sides of the resistor. Okay, so the positive side go to the W1, negative side go to the ground side. Okay, so basically that's how the circuit you should do connection. So usually I start with W1, which is a power source, so that's easier to follow. All right. So one thing, just make sure your ammeter is in series. Okay. And if you have your handheld DMM, it probably looks something like this. Not exactly the same, but probably looks like this. So if you see there are some different pin here, the comp one is usually the ground pin or the negative side of the ammeter or wattmeter. And this pin right here, you see here, there are some little symbol here. So the way here means when you want to measure voltage, you use this pin, so which means wattmeter. And also there is ohm sign, which means you can use this to measure the resistance. And then there is a current pin here. Mention there's letter A here means amp, so that's a unit of the current. So when you measure the current, you want to use ammeter. So that will be your positive side of the ammeter. So current go to here, then go to ground. Okay, so if you back to this plot, okay, the ammeter, the positive side, let me draw here. The positive side means this pin right here. The negative side is ground. Okay, the comp one. So that's how you should do the circuit connection.
For the ammeter, do we leave the circuit as a open circuit and then complete the circuit using the leads from the DMM?
No, this is not the open circuit. Is that so that's the current go to here, like this is the way current goes through. So that's not an open circuit.
Yeah, so we basically use the ammeter to complete the circuit, right? From
Yeah.
yeah.
Yeah. Right. Any other question for the task 2? Okay, so the task 2 itself is not too hard, but you may get confused when you start to connect the ammeter and the wattmeter. Just ask TA for help if you need you get confused. Right, then let's talk task 3. Talk about task 3. Right, so task 3 is getting a little bit hard. You're going to build this 3 circuit on a breadboard. You might need to. Okay, so there's a course website, and there's a guideline. I post this link on the Piazza. I can post again on the Brightspace. So there's a guideline tell you how the breadboard work. Okay, basically, there are like many pins here. Okay, like many holes here. Each parallel. I mean, if you look at this way, those lines in here. Okay, for example, A, B, C, D, E, they are connected together, like in the horizontal direction. They are connected together. Okay, and then like from row 1 to row 2, they are disconnected. Okay, so probably better check this document before you start to build task 3. Okay, let's back to the task. I can show like probably one of the circuit on this really quick. Okay, so for example, I usually start with VS again, so that's a power source. So for example, that's your breadboard. I will build 2.8 since it's a combination of series and parallel. So for example, VS is the V plus pin from your AD2. Okay, so that's a V plus pin. I will connect V plus to one of the pin here. All right. So then this is this part of your circuit. Then I have a first light bulbs. Okay. And okay, let me show you what the light bulb looks like in your AD2, I mean in your lab kit. Okay, that's not the one in your lab kit. I will search it and probably show you in later. Okay, so then I will go to the first light bulb. Okay, after I have the power source. Okay, so the first light bulb I can build probably right here. Okay, so that's the first light bulb. And then I go to here. So the reason I have this in here is they are not the column E and column F, they are not connected together. Okay, so you don't want the two sets of the light bulb short together. So that's a short circuit. Okay, so then that's the first light bulb. And then I go to this pin right here. So the right side of the light bulb go to another 2 light bulb. Okay. So as I mentioned, this row here, FG, HIG, they are connected together. So I can have my second light bulb right here. And probably third light bulb right here. Okay, it will be 2, yeah. It's not very clear, but probably you can get the idea. So this row here is this pin here, this node here. And then then I go to this node here. This node is the right side of these 2 light bulbs. So they should also connect together. So probably I can go to this row number 6. Okay, then this is the most of the circuit, but don't forget you need to connect the ground. Okay, so then let's go to the ground of the AD2. So that's, yeah, the drawing is not really good, but that's how you start to connect the circuit. But first of all, make sure you understand how the breadboard work. Okay, so after you build the circuit, okay, you're going to apply the 5-volt DC. Okay, make sure when you're building this circuit, there's an adapter in your lab kit. Use that to power up your AD2. Okay, otherwise you may not get enough current from your laptop. Then you're going to use the voltmeter, an ammeter in the DMM to measure the voltage and current for each light bulb. Okay, make sure you understand when you measure current, okay, everything is in series. When you measure voltage, voltmeter is in parallel. Okay. All right. So, and another thing I want to mention before is the ammeter measurement for this kind of circuit. Okay, so you want to make sure you put your ammeter. For example, you want to measure the current for this light bulb. You want to put your ammeter right before. Okay, that's not a very good drawing, but let's say the red line is your, okay, red circle is your ammeter. So you want to put your ammeter right before or right after your light bulb. So that's measure the current only through this light bulb. Okay, if you put your ammeter right here, that's the current goes through all 3 light bulb. Okay, so make sure you want to only measure each light bulb individually. Okay, then after you measure the current and voltage, you can calculate the power. Okay, remember the equation, power is equal to current times voltage. Don't worry about step D here. Okay, we are going to drop step D here. Okay, then you can just answer the question here. Okay, I think that's task 3. Okay, task 3 is a little bit harder compared to task 1 and task 2. You need to understand how the breadboard work, and you want to start to like see the schematic, then you can build the schematic on the breadboard. But probably after like this lab, you will start to getting a better idea of breadboard. So the circuit building is not too hard in the future. Okay, the first time is probably the hardest one. Once you get into it, it's not too hard. All right. Any question for the 3 tasks? Okay, I saw there are a bunch of questions in the chat. I think probably some of them are already answered by our UTA. If you have any other question, you can ask me later. Okay, if there's no question, you can start to do your experiment, and I will open 3 or 4 breakout session. So if you want one-on-one help, you can go to the breakout session, and one of us will go to the breakout session to help you. Oh, the adapter. There's a question asking me. The adapter is not in the AD2. The adapter is in the lab kit package. Okay. All right, you can start to do your experiment. Let me open the breakout session.
Quick note about that. You guys will not be getting a breadboard adapter. You guys have the fly wires that go with the 82, so don't worry too much about that. One piece of advice, it might be worth your time to start taking a look at the lab practical that will be happening in Lab 6. That's going to be an independent quiz that you're going to be doing by yourself. It might be worth taking time to look at that. That is something you're allowed to practice. We would really recommend doing so.
Can I ask some question about the recording?
Yeah.
Like, can you record in the chat room also? Because I watched the recording yesterday. There's no chat room showed.
Okay.
If the chat's involved in that or not. I wonder if that's something you can modify in the recording menu, Aaron. I'm not entirely sure, in all honesty.
Yeah. I could
It might be
probably
a
if
file
you
that goes with it. There might be a text file or something that goes with the recording when it gets downloaded. I'm not sure though.
yeah, I can check that. But if you have some general question, you can ask in the Piazza, so we can answer that very quick.
And also for the Lab 2,
Yeah.
the task 2, should we also use the breadboard to build the circuit?
Yeah, it's easier if you can use breadboard.
Okay.
Yeah, you can do it without breadboard, but probably it will be easier use breadboard.
And also on the Brightspace, there are also LT Spice task on there.
If you have your AD2 on lab case, you shouldn't do LT space version. Don't worry about that one.
Okay.
Yeah. Okay, so since all of you is in here, I'm trying to find the light bulb in your lab kit, what it looks like. But first of all, this is not the light bulb. Okay, so this is the LED. So don't use this for the task 3. If you use this, you will short the circuit. This LED itself doesn't have any resistance. Okay, so if you only have this on your breadboard, basically you short the like the power supply. Okay, so make sure you are not using this. Okay, I'm still trying to find the picture of the light bulb in your lab kit, but just make sure you are not using the LED. Okay.
It is this guy right here.
Oh yeah, so that's the, if you can see in the WebEx, Ben is showing the LED, I mean the light bulb in the on the screen.
Let's see if we can get the screen to focus. Probably not. It says AML 7361 is what it says.
There's a student in breakout session 3. That's one of our UT can join and help. Yeah, there's a question asking about LED. Yeah, you're not supposed to use LED for last task. Okay, I saw some students may confuse about task 1, how to connect AD2 and how to do the measurement with DMM. I can show you really quick right now with some online pictures. So basically, in your AD2 box or AD2 package, either you have this breakout here, so this little green thing. So you can connect this on the breadboard, and then there are some label so to say where each pin is, or you have those little those wires. So either one works. They are same function. So you as long as you have one of them, that should works. Okay. So for example, in task 1, today's lab in task 1, you don't need to do any connection for step 1, step 2. But for step 3, you need to measure the RMS value. So what you are going to use for measurement is the DMM, right? So let's say here, if you remember, I mentioned the voltage, the AC signal is coming from W1 or W2, okay? So for example, this is pin out. So W1 is your signal or voltage where it comes from. And then you need to use your handheld DMM to measure it. So as I mentioned, this pin with the letter V, so that's a wattmeter. So you need to connect W1 to this letter V pin here, okay? And then don't forget you need the ground. Okay, so this COM go to the ground on the AD2, okay? So then that's how you can do the measurement. Okay, so if I draw the plot here for task 1, it's basically W1 go to the letter V on the DMM, and then the COM pin on the DMM back to the ground on your AD2. Okay, so that's how the measurement. This whole thing is the DMM. So that's how you do the voltage measurement in task 1. Yeah, but make sure you watch the AD2 introduction video. You can find it under experiment 1 in the Brightspace.
I have a question for task one.
Yeah.
Okay, so I managed to measure my voltage, but do I have to take a picture of the voltmeter, or do y'all generally trust that we have gotten the correct value?
No, you don't need to take any picture for the real circuit, but what you want is you want to like in the write-up you might want to draw the circuit diagram like what I showed before. Draw that in your write-up.
Okay.
Yeah.
And when we draw the write-up, when we draw the circuit diagram, do we have to include any like do we have to use a particular program, or can we hand draw it?
No, you can probably better don't hand draw it. Probably try to use LT-Spice, but if you like think it's easier and you can hand draw it, but make sure everything is clear.
All right, thank you.
Yeah. Okay, I saw there are a couple students was asking how to like what you can use to draw the circuit diagram. So for example, in the write-up, you might want to include your circuit diagram, but you don't need to take a picture of your like real circuit on the breadboard, but you need to draw it either by your hand or you can use LT-Spice. So for example, right now I'm using LT-Spice to draw the circuit for the task 2. Okay, so in the LT space itself, it doesn't have the ammeter, but you can create a symbol by yourself. Okay, so for example, in here, just create a new symbol. Okay, and you can create a like draw the circle like this, and for example, I want a wattmeter, then put away here. So that's a wattmeter. Okay, so that's not going to work in the simulation, but it can help you to draw the schematic. Okay. Even same thing for task 3. You want to include your circuit diagram in the write-up. So you want to draw it somewhere. So LT space is a good choice for your schematic.
Can you show us how to do the custom component again?
Yeah, so click on the fill and new sample. And then you have this. Okay, I can create a new one. So then I can draw a circle. So for example, in task 3, you want to draw a light bulb. Okay, so I just use draw a circle and use couple line to, so that's good enough for light bulb. Okay, then I save it, say light bulb. Okay, then back to the schematic. Okay, so if you have a new schematic and go to components, go to wherever you save it. Clearly, I'm not saving here. Okay, so here is the light bulb. So yeah, then you can start to draw the circuit for task 3, for example. So you have a voltage source, and you can go. You need 3 of this. For example, those 3 in series. Okay, then you can use the cable to connect them together. And okay, so that's probably a quick example for how you can draw the circuit diagram. So again, this is not going to work since this is just a simple I draw, but that's a good screenshot you can put in your write-up.
How do you get the component after you draw the component? How do you like import it again?
Just take a screenshot. Is that what you're asking?
No. Like you draw the light bulb as a ASY file, right? How do you
Yeah.
import that component
Oh,
into your schematic?
just go to the component here, and go to the top directory, go to wherever you save it. And then, for example, I name it light bulb. So then here is it.
Okay.
Yeah.
I have a question for task 1, part 3. So it says measure the RMS voltage, and then question part 4 says, is this AC or DC RMS? But my voltmeter can measure both AC and DC.
You need to first of all, in task 2, calculate. I mean, not task 2. In step 2, you calculate the AC and DC RMS, right?
Yeah.
And then you use DMM to measure the RMS value. Then you compare the measured value with the calculated value. So it should be similar to or close to one of them. Okay, so then that's what DMM measured.
My DMM can measure both AC and DC.
No, I think the DMM can only measure one of the RMS.
No, I just tried. I can measure and get both my AC and DC RMS by using different modes.
Did you like one thing? I'm not sure you mess up or not. The DC RMS is not equal to offset, right? For example, if you in task 1, let's see, 1 second. Task 1, your offset is 2. If you measure, okay, if you measure 2, that's not the DC RMS, that's just your DC. DC offset is not equal to DC RMS.
But isn't the DC RMS equal to, or the square of the DC RMS is equal to the square of the AC RMS plus the average value?
Plus,
okay, wait.
Yeah, you need to use the equation in menu 2.2. I can share my screen again very quick. Okay, so you need to use this equation. Okay, so the AC RMS is using this equation right here. So for example, this is a sine wave, you need to use this equation. Amplitude, absolute value of amplitude divided by square root of 2. So if you go to the task, the AC RMS equal to 2 divided square root of 2. Okay, and then back to the equation again. Then you know the AC RMS, then you need to know what's the average. Average is just the offset. The average here is 2. Okay, then you can use this equation to calculate the DC RMS. The DC option, yeah.
If I use a DMM to measure it, it will give me the DC offset, but that is different from the RMS.
Yeah. Yes.
Okay.
Yeah. Yeah, the DC option in your DMM is measure the DC voltage, is not the DC RMS.
Okay, got it.